Hi, today we're going to talk about medical geography. The question always comes up, what is medical geography? It's a relatively new subfield in geography. It has been around for about 40 years or so. And medical geography, like all subfields of geography, looks at that topic in a spatial context. So it essentially looks at the distribution and diffusion of disease and health. So, why do diseases occur where they do? Why do we find certain diseases at higher rates in one part of the world and lower rates in other parts of the world? We also look at how a disease moves through space. Although it might be the same disease, the way it diffuses or moves from one person to another person or one place to another place differs according to cultural norms, social norms, environmental factors, access to healthcare, all sorts of things can affect diffusion patterns. So that is essentially what medical geography looks at. Differences between health in different parts of the world and differences between disease distribution and diffusion in different parts of the world. So to start with, I want to talk about three main categories of diseases. Now, these are not the only categories. There is a long list of different types of diseases, but this is a way to summarize the different types of diseases that we primarily see. And those are infectious disease, chronic or degenerative, or genetic or inherited. If we look at infectious disease, an infectious disease is essentially one that you become infected with. You have to become infected with a particular organism. So it's not something you're born with or passed down through generations. You actually have to be infected with it. An example of an infectious disease is malaria. And we're going to talk more about malaria later on in the lecture. We then have chronic or degenerative. Now, these are related. They're not exactly the same, but I put them in the same category. A chronic disease is one that occurs over a long period of time. So it's not something that you're just going to have for a few days. So a cold, for instance, would not be a chronic disease. It's one that occurs over years, a long period of time. Now, in some cases, that chronic disease is also degenerative. And a degenerative disease is one that gets worse over time. So, by their very nature, all degenerative diseases are chronic, but not all chronic diseases are necessarily degenerative. We could technically have a disease or a condition that you have for a really long period of time, but it doesn't necessarily get worse. Just so you have allergies, for instance. You might have allergies every single year or a certain time of year, but they don't necessarily progress. On the other hand, if the disease gets worse over time, then that is degenerative. So I use diabetes as an example for a chronic disease, and in some cases, also degenerative. Then we have those diseases that are considered genetic diseases or inherited diseases. These are diseases that are passed down through genes. So there's not a whole lot that one can do to prevent this since it is passed on. An example of this is sickle cell. Again, there are many examples for all of these types of diseases. And as I said, these are not all inclusive categories, and many diseases can fall into more than one. So it can be a chronic infectious, for instance, or a genetic degenerative disease. But most diseases will fall into at least one of these categories. We then have different types of outbreaks. Epidemic and pandemic are the two main ones. Endemic isn't necessarily an outbreak, but it is related. An epidemic is when you have a sudden outbreak and that outbreak is in large numbers. Now you might ask, well, what is a large number? That's really subjective because it depends upon the disease and where it's occurring. So it is relative. So a large number would be considered much larger than what would be normal or typical for that particular disease and that particular country. So, for example, if we're talking about a cold epidemic, we would have to have quite a few of them because a cold is fairly common. Okay, we're going to talk about that when we get to endemic. But if we had Ebola in this country, I don't think it would take many cases for it to become an epidemic because that is extremely rare for this part of the world. So probably we would only have to see a handful of cases and we would start using that term epidemic. So it's really relative to what is the norm. When we're talking about it in this context, I know in media, that term epidemic is thrown around for a lot of different circumstances for a shock value. But in its technical sense, it's when there's a larger number than what is expected and it occurs suddenly. If an epidemic starts to spread, and it spreads to the point that it reaches global distribution and then turns from an epidemic to a pandemic. Now, a pandemic doesn't necessarily mean it has to be in every single country, but it's not localized anymore. So it's one that you can find in several regions of the world. So if we look at HIV/AIDS, for instance, that would be considered pandemic because it's global. Now, when we talk about it, we can still refer to it as an epidemic in a particular area, like AIDS has reached epidemic proportions in such and such country. But when we talk about it in general terms, we can refer to it as a pandemic because it is in so many different countries around the world. Now, endemic isn't necessarily an outbreak, but it is related to the other terms. And endemic means that it is always present in the environment. Always present. So it's not suddenly appearing, it's not more than average numbers. No matter what time of year it is, no matter which year it is, it's always there. And I put the example of the cold again, the common cold. On any given day, somebody somewhere in the United States has a cold. So it's just a virus that is always in the environment. Unfortunately, in some cases, there are diseases that are much more serious, such as malaria, that are endemic in the environment. So epidemic, pandemic, endemic. I also want to talk a little bit about factors involved in diffusion. And this is agents, vectors, hosts, and reservoirs. Now, not every disease will have a vector, but many do, and many of the ones that we're going to talk about do. But let's first start off with the agent. The agent is the actual disease-causing organism. So when we talk about disease, we're usually talking about a virus or a bacteria or a parasite or a fungus of some sort. So that's the disease-causing organism. So if we talk about, when we get to malaria, for instance, there's an actual parasite that causes the disease malaria. So that is the disease-causing organism, the actual parasite. Or in the case of tuberculosis, the actual bacteria is the disease-causing organism. Now, in some cases, a disease needs a vector, and a vector transmits that disease-causing organism. So in the case of malaria, a mosquito is the vector. In many cases, it is an insect. So that insect or that vector is needed in order for the diffusion to occur. Without the vector, the diffusion stops. And that's why with many vector diseases, the best way to eradicate the disease is to eradicate the vector, if it's possible. So the vector does not necessarily have the disease, per se, but is a carrier of the disease. We also have the host. Now the host is the permanent carrier of the disease. So if we look again at the example of malaria, a person would be the host. Okay, so the parasite is in the person. The vector, the mosquito, would bite the host and then transmit the agent or the disease causing organism to another host. Okay. Now, in most cases, the host will have symptoms of the disease and actually have the disease, but in not all cases. So it just depends on the particular disease as well as the particular host. The reservoir is where it all begins. Where does it all come from? So the reservoir is an animate or inanimate source which harbors that disease causing organism. Where does the organism come from? And that reservoir then serves as a potential source of disease outbreaks. Now, in some cases, we know the reservoir of a disease. In other cases, we have no idea what the reservoir of the disease is. But if you know the reservoir, then you definitely have an upper hand on controlling the disease because you know where the actual organism comes from. And some diseases, like I mentioned, Ebola, we don't know what the reservoir is yet. All we know is that it occurs every 20 years or so. There's a large outbreak in Central Africa. And we think that the agent is somewhere in the forest, somewhere in the jungle, and that's about as close as we are right now. But we don't know the actual reservoir. So in these cases, it can be a lot harder to control because you're not quite sure where it exactly comes from. So I want you to be aware of all these different factors in diffusion and know their role, because there will be a question on this on the exam, and students sometimes mix up the agent, the vector, and the host. So the agent is the organism, the vector transmits it. So if you just think of an insect or something like that, if you think of vector, then you know it's transmitting. The host is what carries it, so it's what the vector bites. And the reservoir is where it all begins, or where it all comes from, where the actual disease-causing organism comes from. This is going to be a good place to stop, and then we're going to pick up with looking at some charts and graphs of disease.